Hi guys, today I'm going to revise with you Newton's law of gravitation and we're going to apply the equation to some problems as well. Okay, so here's the formula for the law of gravitation. Now F is the force of attraction between the two bodies. We've got G, which is the universal gravitational constant, which I've put down here, 6.67 times 10 to the minus 11, very weak. The mass of the first body could be a planet, could be a person, could be anything, but it's going to be measured in kilograms. And likewise, the mass of the second body, again, whatever it is, it's going to be measured in kilograms as well. Then we've got the distance between the bodies, that's in meters, and that is squared. So that's the formula. So let's have a go at applying our formula to some problems. A 5 kg and a 10 kg sphere are 0.3 meters apart, and that's the center to center distance. Find the force of attraction between them. So we're going to apply our formula. F equals G m1 m2 over r squared. Remember, G is equal to 6.67 times 10 to the minus 11. Now let's put the rest of the numbers in to find F. So F is equal to 6.67 times 10 to the minus 11 times by m1. Well, let's make 5 m1. And we'll also make m2 equal to 10. And then we're going to divide that by the distance between them and square it. So 0.3 squared. And when I put it all in my calculator, I get a final answer of 3.7 times 10 to the minus 8 even newtons. There we go. A woman standing on the surface of the earth, 6.38 times 10 to the 6 meters from its center, has a mass of 50 kilograms. If the mass of the earth is 5.98 times 10 to the 24 kilograms, what is the force of gravity on the woman? So, like we've been doing previously, we're going to apply our equation. F equals G m1 m2 all divided by r squared. So G is 6.67 times 10 to the minus 11 times by the mass of the woman, which is 50, times by the mass of the earth, which is 5.98 times 10 to the 24. Divide that by the distance between the two, which is 6.38 times 10 to the 6, and remember that's all squared. We get a final answer of 489.9 newtons. The planet Jupiter has a mass of 1.9 times 10 to the 27 kilograms and a radius of 7.2 times 10 to the 7 meters. Calculate the acceleration due to gravity on Jupiter. So, starting off with F equals big G m1 m2 over r squared. Now the acceleration due to gravity little g is equal to mg, and we can just call that m1. Then we can substitute this in up over here. So we get m1g is equal to big G m1 m2 all divided by r squared, and then this is just going to become G equals big G capital M r squared. So capital M is the mass of Jupiter. So now let's apply this, so let's put the values in. So big G is 6.67 times 10 to the minus 11 times by the mass of Jupiter, which is 1.9 times 10 to the 27, okay, divided by r squared. So the radius, so brackets 7.2 times 10 to the 7, that's all squared. So we're going to find that G is equal to 24.4 meters per second squared. Okay, last example. Find the force of gravity between two 74 kilogram physics students that are sitting 85 centimeters apart. Okay, so we're going to use our equation again. F equals big G m1 m2 over r squared. Let's put the numbers in. 6.67 times 10 to the minus 11. Okay, then times by 74 times by 74 again. And then it was 85 centimeters, so that's 0.85 meters. So here we're going to do 0.85 squared. We get our final answer of 5.05 times 10 to the minus 7 newtons. So pretty small force of attraction. And finally guys, if you've not subscribed yet, I'd really appreciate it. It means I can get my videos straight to you and hopefully get you through your revision a lot easier. Bye for now.